In this video, I'm going to be working some practice problems for College Algebra Unit 9. So the first one I've got is this dividing two complex numbers one, which seemed to be kind of an issue on the quiz. It was a pretty commonly missed problem. So what you want to do is you want to start off by multiplying by the conjugate of the denominator on top and bottom. Okay, so that's going to be times 3 plus I over 3 plus I. Okay, and you go to distribute, using FOIL. And you'll get 60 plus 20i minus 60i, and then negative 20i times I is negative 20i squared. And then in the denominator we have 3 times 3 is 9 plus 3i minus 3i minus I squared. And then, okay, I'm going to combine some like terms. Okay, so 60 minus 40i minus 20 times negative 1 would be like plus 20. And then the plus 3i and minus 3i, that's going to add to 0. And 9 minus negative 1 is 9 plus 1 is 10. So I've got 60 plus 20 is 80 minus 40i divided by 10, which is going to be 8 minus 4i. And if they ask for what is the value of a, well, a is the number that doesn't have an I attached to it. That would be 8. The next couple are also based off of a commonly missed question from the quiz. This was from the first quiz in this unit. And I had a lot of people just give me back decimal numbers. They just tried to run it through the calculator, and that was just not the point of the question. What you're going to be faced with on the test is, multiple choice setting. So it would, have some options like, I don't know, just throw in some multiple choices here. A 11 to the 6 minus 5 is 1. B 11 to the 6 times 5 is 30. C 11 to the 5 divided by 6, and D 11 to the 6 divided by 5. So, given those choices, I suppose you could try to put all of the answers into a decimal form and see if you can knock off answers that way. That's going to take a long time, though. It's going to be a waste of time. And there's quite a few questions on this test, so you want to, use your time wisely. So what you're going to do is you're going to say 11 to the 6th, the 5th root of something is like taking it to the 1/5 power. And then when you have kind of power of a power, that's where we're going to multiply the exponents. So this is 11 to the 6 times 1/5. And 6 times 1/5 is 6/5. Okay, so that would be, in this case, answer choice D. And so if you wanted to write 41 to the 3/5 as a radical expression, okay, the denominator is the index of the radical. Okay, so if it's 3/5, it will be a 5th root. So it'll be a 5th root of 41 to the 3rd. Now you can also write this as the 5th root of 41 taken to the 3rd power. It's the same thing. It really doesn't matter. So it would just be like, which of these is equivalent to 41 to the 3/5? And it would have, a bunch of wrong answers and then one of these two. Okay, here's a solve the equation that has a little something that I don't think we did in our notes or our practice problems or on the quiz. This one's very similar to one from the test. So I'm going to start by getting rid of the radicals. So I'm going to need to square both sides. And now remember that was, I guess, the second day in this unit. When you square both sides of an equation, you have to check the answers afterwards because you can get extraneous solutions. Right? So that's 8x is equal to, well, if I square 2 times the radical, I'll have 2 times 2, and the radical times the radical. Right, so I've got 8x equaling 4x plus 16. I subtract 4x. You get 4x equals 16, and x is 4. Okay. Now you want to check the solution because you squared both sides. And so is the square root of 32 equal to 2 times the square root of 8? Okay. Well, you could check this using a calculator if you wanted, or you could go over here and split up square root of 32 into square root of 4 times square root of 8. And we know what the square root of 4 is. So yes, 2 root 8 is 2 root 8. Okay, next we have, another one based off of one that we missed a bunch on the quiz. Okay, this is the quotient of two expressions in Q. All right, so my advice here is to turn both of them into fraction powers and then just subtract. Okay, so Q to the 9 7th rooted is going to be Q to the 9 divided by 7. Remember, the index of the radical is the denominator of the fraction if you put it as a fraction power. And that would make this Q to the 3/5. Now, y'all have a nice scientific calculator that will do this work for you, but when you're dividing two things with the same base and different exponents, you need to subtract the exponents. And, okay, I need a common denominator, so I'm going to do that arithmetic over here, 9 over 7. Okay, I'll need to multiply that by 5 over 5. Minus 3/5, and I'll probably need to multiply that by 7 over 7. And so this will be 45 over 35 minus 21 over 35, which will be 24 over 35. Okay, so this is Q to the 24 over 35, which is going to be answer choice C. That's the only answer choice I see that has the numbers 24 and 35 in it. And that is what Q to the 24 over 35 is. It's the 35th root of Q to the 24. Okay, another problem that's a little different from how we've seen it presented so far is one where your answer choices are decimals. Okay, so I'm going to start by taking the third root of both sides, meaning that x plus 10 is equal to the third root of 81. Okay. Now, when you take the square root of both sides, or any even root of both sides, you need to remember that plus minus. But not for a third root, because the third root of a negative number is negative, and basically the third root for a given number is unique, so you don't need to worry about the plus or minus. Okay, so right off the bat, I can eliminate answer choice D. And honestly, I think it's probably going to be B, because that's, the mistake for choosing D would be getting the right answer but putting a plus minus on it. That's just what I think. Right. So I'm going to say solve for x, and x is going to be negative 10 plus the third root of 81. Now, you go into the calculator and you ask it to do negative 10 plus the third root of 81. That's going to be negative 5.67. Oh, man, I was wrong. Negative 5.67. Okay, so that was answer choice A. Not really sure how you get 4.14, but who knows. All right, and so I kind of have realized what the 4.14 is. That would be if you tried to subtract 10 from both sides before taking the third root. Okay, so you're going backwards order of operations, but the grouping symbol, you kind of got to deal with that first. Okay, you've got to deal with that third power before you can go into those parentheses and subtract 10. Okay, so, just be aware of that. Okay, next we've got kind of a factoring problem that we've done at various points, but I'm not sure that we've done it with complex numbers. So I'm going to say, okay, I see four things with kind of a common pattern. 1 to 4 is the same ratio as 9 to 36, so this needs to be group and factor. So what I'm going to do is I'm going to, kind of group these and group these, and I'm going to factor them separately. So what's common to x to the 4th and 4x to the 3rd? That's the x to the 3rd. And then over here on the right side, I've got what's common to 9x squared and 36x. Well, that would be 9x. Okay. It's occurring to me now that I could have factored out a greatest common factor of x at the beginning, but I can just do that in a little bit. Okay, when you factor out the 9x, you're left with an x plus 4. Okay, and since we have that same factor on both, I can factor out the x plus 4. And you're left with x to the third plus 9x. Okay, well, that's got a common factor, so I've got x times x plus 4 times x squared plus 9. And if we're interested in the roots of the polynomial, that's where the polynomial is equal to 0. So that means that either x equals 0, x plus 4 equals 0, or maybe x squared plus 9 equals 0. And we know how to solve that. We just kind of subtract 9 from both sides. The square root of negative 9 is going to be 3i. So that'll be plus or minus 3i. And then there again, look, complex roots of polynomials coming in conjugate pairs. Which of these is not a real number? Okay, that's an interesting question. Well, we know that I isn't a real number and that complex numbers are not real. If we're seeing i's in there, that's not a real number. But we also know that I squared equals negative 1. So what I'm going to do is I'm going to replace I squared with negative 1. So Roman numeral 1 is the square root of negative 2 times negative 1, which is the square root of 2, and that is a real number. Okay. Roman numeral 2, 3i to the third is 3 times I times I times I. Well, I squared is negative 1. And that would mean that I have negative 3i. That is not a real number. Okay, so I'm just going to go ahead and preemptively say 2 is not a real number. But these Roman numeral 1, Roman numeral 2, Roman numeral 3 questions, oftentimes it's like there could be more than one of these that is a correct answer. And then the last one, okay, negative I squared divided by 2, that's 1/2. And 1/2 is certainly a real number. So I can conclude that Roman numeral 2 is the only one that is not a real number. All right. Let W be the complex number 5 minus 6i, and let W bar be the complex conjugate of W. Find the value of W plus W bar. Okay, so this is really asking, like, do you know what the complex conjugate is? And I'll just remind us that the conjugate of A plus BI is A minus BI. Take the number against the imaginary part and we make it negative. Or if it was already negative, we make it positive. So if W equals 5 minus 6i, then W bar is going to be 5 plus 6i. And if I add them together, that'll be 5 minus 6i plus 5 plus 6i. And okay, that'd end up being 5 plus 5 is 10 plus no i's. So it's just 10. Okay, next I've got one that we avoided on the quiz, and but I do want to make you familiar with the double root situation. Okay, this is showing the graph of a polynomial. P has 4 imaginary zeros. So the degree could be, we know the degree is the total number of zeros. It's the fundamental theorem of algebra. So if I can just tally up all the zeros, I'll have the degree. Okay, so I've got 4 imaginary. And then as far as real roots, I've got 1, 2, 3. But the thing is, this is a bounce, which means it's a double root at least. Okay. Now, just for simplicity, we're just going to assume it's a double root, not a quadruple root or, root with really high multiplicity. But it counts twice as far as our counting zeros to determine the degree. So I've got 4 imaginary roots and also 4 real roots. One of them just happens to be repeated twice. And that is a total of 8 roots, which means 8th degree. Okay, if you had said that the bounce was only a single root, well, that would have led you to believe that there were 3 real roots and 4 imaginary, which would be degree 7. But an odd degree polynomial can't have both of the edges of the graph going up. It can't have that going the same direction. That's not what an odd degree polynomial looks like. So that would be the first hint that you were doing something. The last one I've got for you is just kind of an old-fashioned solve the equation, check your answer. I have a feeling one of these is going to come back extraneous. And you also need to square a binomial. Now, it seems to me that y'all are doing really good on this as far as not making the classic error of squaring x plus 2 and saying that's x squared plus 4. But, I just can't remind y'all of that enough. So I'm going to start by squaring both sides, which means that I will need to check my solutions. So I'm going to get x plus 22 equaling x plus 2 squared. All right, when I actually go to square that, I'm going to have x squared, 2x and 2x is 4x, and 4. If I'm going to solve this thing, I have to set it to 0, so I'm going to say 0 is x squared. I'm going to subtract an x, and I'm going to subtract 22. And then I'm going to try to factor. This thing is looking pretty factorable with, I think, x plus 6, and x minus 3. And now these things are going to be equal to 0 if x plus 6 equals 0, or if x equals 3 is 0. Okay, so we need to check. So I'll start with negative 6. So is the square root of negative 6 plus 22, which would be the square root of 16, the positive square root of 16, is the positive square root of 16 equal to negative 4? No. Okay, so this one's out. And then 3 plus 22 is the square root of 25. Is that equal to 3 plus 2? Yes, it is. Okay, so x equals 3 is a solution to this equation. And that's all I got for you. Other than these problems, if you're trying to review for the upcoming college algebra test, the best thing I can point you toward is the quizzes. The test in this unit is really, really modeled after the quizzes. And the keys are all up now, and so